Hello, my name is Ken Cochran, and this is my Docker 101 screencast. The goal of this video is to introduce you to Docker and show you the basics. Let's get started. Before we get started with Docker, we need to first install it. If we go to the Docker webpage, you can click on Documentation. There's a whole section on installation. The two that we're going to cover today are Vagrant for our local Mac install, and we're also going to use the Ubuntu Linux install for installing on a DigitalOcean server. Let's go into the Mac version first. First thing we need to do is bring up a command line window and copy this command, which will copy the git Docker repo down to our local machine. It might take a minute. Once it's finished downloading, let's move into the directory. Inside of here, you'll see all the same files that you would see if you went to the website. All we need to do now is type Vagrant up. This assumes that you have Vagrant already running on your machine. If you don't have Vagrant running, I'd recommend you go to their website and install it before you do the tutorial. It took a little while to install Vagrant and download that image. And once that was complete, I just have to run Vagrant up. As you can see, it's going through and it's installing all of the different things that it needs in order to get Docker up and running on Vagrant. Now that it's up, we can Vagrant SSH. Now we're inside of this. If we run sudo docker ps and version, you'll see we now have 061 installed in Docker on a Vagrant image. Now that we have Docker running on Vagrant, let's go ahead and get it installed on a DigitalOcean server. First thing we're going to do is we're going to log into our control panel and we're going to click this create button. Now what you can do is add a host name. I'm just going to call mine Docker. I'm going to pick a size. For this demo, I'm just going to use the smallest one, which is 512. What's nice about this, it's only $5 a month. I'll pick the New York 2 as my region, and down under Image, I'm going to click on Applications, and then click on the Docker Application button right here. I'm going to add my SSH key, enable virt.io, create Docker. It's going to take about 60 seconds, and once it's done, I'll have an image, a Docker server I can actually log into. What's nice about doing this application image versus doing it a raw Ubuntu image is I won't need to actually do anything else after I'm installing it. It'll have Docker already running for me, and it will make my life a lot easier. Alright, after about 6 seconds, it'll pop up on a page and it'll show me what my IP address is so that I can log in as root. So it's SSH root. And from this, I just have to put the IP address for the server that I have. And there it is right there. So now copy that, come over here, say yes. Now if I do docker ps, Docker version, you can see I have it up and running. Now that we have covered how to install Docker, let's start playing with it and see what it can do. The first command that most people like to type is Docker version. This will tell you what version you have up and running and whether or not it's the latest stable version. As you can see, the one I have here is 061. Another helpful command is Docker info. This will tell you if you're logged into the registry, if so, what it is, as well as the username and any containers or images that you might have. Let's see if we have any processes running. We do that by running Docker ps. As you can see, there's nothing listed there. If we run Docker images, it will show us a list of images that we already have loaded on our Docker system. If we needed something that isn't installed, we just have to do a Docker pull and it'll download that to our machine. Let's get started and actually run something. What we're going to do is run docker run Ubuntu 12.10. We're going to say echo hello world. As you can see, it printed it right out. That was pretty fast, and this is what it did. It created a full copy of the image, it set up a full sandbox execution environment, ran the command, and then exited all under a second. It's pretty fast, but pretty boring. Let's do something a little more exciting. Let's do the same thing, but instead of executing, let's do an interactive mode. What we're going to do is, instead of exiting and going right away, we're going to go into the command, the container, and this way we can actually run some stuff. So as of right now, we're inside of the container. The easy way to tell is you'll notice the prompt has changed a little bit. Now if I did a PS AUX in here, you'll see there's only two processes running, bash and PS AUX. We can do a lot of things inside here. For example, we could rename our home directory home2. Now it's home2. If we were to exit this command, what we could do is actually look to see what we changed. We can do that using the docker diff command. When you run a container, it disappears into the background. So if you do docker ps-a, you'll be able to see previously running containers that are still in your machine. I use that to find the container that I actually ran, and from that I can see the two containers. We're going to pick the one that was the bash command we just ran, do a diff on it, and you'll see from this diff that some files have changed. Bash history changed, which makes sense because I ran some commands inside of the container using bash. Home is no longer there, and it's been replaced with this home2 later on. This dev stuff, don't worry too much about it. If I wanted to, I could actually commit these changes and make a new image. I won't do that right now, I'll show that a little later. Let's do something a little more fun. We'll do the same command that we just had, but let's do something a little more destructive. To show you that these containers are self-contained and they're not associated with any of the images, let's go in and destroy the bin directory and etc directory. Oh, look, now things aren't working. If we exit out of there and we run the same command again, you'll see everything's running fine. Bin and everything's still there. When we exit out of this and do a docker ps-a, we can do a docker diff on the one that we destroyed everything on and see all the changes. But luckily, because we did that inside of container, we're safe. To clean up after ourselves and delete those containers, we just have to do docker rm and a list of container IDs that we want to delete. Now we have nothing in there. Let's do something a little more exciting this time. We're going to run a daemon that runs in the background. We're going to do the same command we did before. We're going to do docker run, but we're going to do -d, which means send it to the background. Ubuntu, same the 12.10 that we were doing before. And we're going to pass it bin sh-c. What this is doing is it's going to run in a while loop in the background that's going to print hello world. It's going to show the date every 1 second. As you can see, it's now running in the background. If we do docker logs on this particular container, we'll be able to see that it's actually doing what I just told you it's doing. We can also docker attach to the same container, and we can see in real time the results coming out of this daemon. To get out of it, just Control-C. Another thing that you can do with the running container is run docker inspect. Docker inspect will give you a lot of information about the container, such as the IP address and any other settings that you might have passed in. This is helpful if you want to do a lot of interactive things to containers after they're running. Now, to stop this, we just type docker stop and then the ID of the container. And we run docker ps, and you'll see that nothing is there. But it is there in the background. which means it's no longer running, but it's still on the machine. If we wanted to, we can say docker start in the container, and what will happen is it's going to be running again. So just to prove, we're going to docker attach, and there it is again. So once again, as a recap, we Docker ran a container into the background, we stopped it, we started it, we attached to it, we looked at the logs, we inspected it, and we restarted it. Let's go ahead and stop that again. Now that it's stopped, let's destroy it, because we don't need it anymore. Oops. There you go. It's all gone. Let's say you want to create your own image. There are a couple ways of doing that. I'll show you the first one now. That's a manual creation. So what we would start off with is a normal docker run. Give it our image, 12.10, and then bash. This is going to start up a new container from the Ubuntu 12.10 image. Now inside of here, we can do whatever we want to do. Let's say we want to rename the home directory to home2. So mv home, home2. So now if you look, you can see that it's now home2. Very simple change, but let's see what happened when we did this. Another command that we can run is docker diff. But before we can find out what we need to diff, we need to see what was the image, the container ID for the image that we just ran. So we just ran the Ubuntu 12.10 using bash, so that's the correct one. And the ID for that container is this. So let's do a docker diff. You can see a few things have changed. We have a bash history changed, makes sense, I ran some commands. Home is deleted, and dev, and I'm not sure what that is, but the two important things here is this and this. We basically deleted home and added home2. Alright, now that we have our change in the container that we really want to save this, what we do is we commit the changes. So we do docker commit, give it a -m for a message, similar to git and hg when you pass in the m. Then we give it the image ID, which is this ID up here that we have, and then we have to give it a name. So I'm going to call this new home2, and then Ken Cochran / new home2. Ken Cochran's my namespace on the Docker index. That's my username, and then the new home2 is the name of my image. So we commit that, and it gives us a whole new ID here. Now if we do docker images, you can see that this new guy is there. Ken Cochran, new home2 with that ID. Now that we have this, we can actually push that up into the Docker index. And the Docker index is a common repository that you can upload your files to and share them with other people. Before you can do anything, you need to log into that. My name is Ken Cochran. And now I'm logged in. So now I can do docker push and then my image, which is that, and it will push up my change. As you can see, it pushed up. It was pretty quick, and that's because it only really needed to push up my two little minor changes. It didn't have to push up all the other stuff because it's based off that based Ubuntu 12.10 image. Now that it's out there, if we come over to the Docker index, you can see that it's listed here as recently uploaded. And there's my image. Let's say I go to a different server and I want to docker pull Ken Cochran, and then it is new home2. So what it's going to do is it's going to connect to the index, it's going to pull down any changes, and now on this server I can see I have Ken Cochran, new home2. Let's run that. Docker run this bash. So now when I come in here, it should show, yep, it shows home2 instead of home1. So that's a really easy way for you to create an image manually, save it as as a image with a snapshot, upload it to the index, connect it from some other server, and pull it down. So it's really easy for you to bundle your stuff up and distribute it to other servers. Another way to create a Docker image is by using a Dockerfile. A Dockerfile is a set of commands that allow you to easily script out the creation of a Docker image. Dockerfile is very basic commands that you can find in the Docker documentation. If you look at the file that I have here, it starts off pretty simple. You say from, and then the image that you want to start with. There's a maintainer tag that shows you the name of the person who created it. In this example, it's me. Then I just have a bunch of run commands. And what the run commands do is they kick off commands inside of that particular container. So for instance, this first one is going to do an apt-get update, and then an install, and then installing pip, virtual environment, micro-whiskey. What I'm doing here is I'm setting up a Docker image for this project I have called Django Docker. And Django Docker is just a really simple image that, it's basically an example of doing a Docker Django project. So if I have a Django project and I would deploy it to multiple servers, I would use this. And after installing all of this stuff, it's just a bunch of commands that Django requires in order to get fully set up. Creating the database, copying some configuration files, and in the end, I'm exposing port 8000, and then I'm running the command, which is basically just shell script called run. If we go look at that, just a run script that's just kicking off supervisor. And then the supervisor configuration file lets me run multiple applications at the same time in the same container. Normally Docker only allows you to run one process at a time, but this kind of lets you cheat the system by running multiple processes in the same container. Now to kick this off, it's really simple. What you end up doing is you run the docker build command. And the docker build command, you say docker build, and then I'm going to create a tag. By creating a tag, it saves me a step later on, so I just do this all at once. And then I run, I'm going to pull it right from GitHub, so I don't have to download the code locally. And then I go, oops, Django Docker. What this is doing is it's going through step by step of all the different lines in the file and executing them. If I ran one of these steps previously, it's going to be cached and it's going to skip over it really quickly. As you can see from here, a lot of these say using cache, using cache, using cache. So see how fast that was. Now the image that I have here is done. So if I were to do Docker images, you'll see there it is right there. Those two numbers match. Okay. Now that we have this container, or this image, let's run it. So what we do is we say docker run, and we make it a daemon because we want it to run in the background. Give it a port. We're going to say 8000. And we just give it the image name, Django Docker. We kick it off. And as you can see from here, we have this ID. So if I do docker ps, you're going to see it's running in the background. It's been up for 8 seconds. Great. Let's go to our browser. We know this is the IP address for our server. So if we go, there we go. It's running up on our DigitalOcean server. You click on it. You'll be able to see what is your favorite Beetle. You can vote. It's a very simple Django app. It's not anything sophisticated, just to show you that it actually works. Now let's run that same thing over here. But before we do that, we need to push up our image into the registry, the index. So we're going to do docker push, and this might take a couple seconds, but it should be pretty quick as it goes through. While we're doing that, let's go over to the other machine and let's do docker pull. We're not going to kick that off until the other one finishes, but we want to make sure we're ready. Okay, great. So now, as you can see, it's finished. Over here, we'll do a Docker pull. This is on my local machine, so these two different tabs are for two different servers. So now it's going to pull down all the information. You can see the progress report as it's downloading. Boom, all done. So now if I go to Docker images, you can see it's right there. Great. Let's run this again. So, but we're going to run on a different server. So we're going to do Docker run -d -p. If I didn't give it a -p, it would give me a random port. But because I want to make sure it's running on 8000, I pass it in there. You can see Docker ps. Great. Now over here, this is my IP address for my local machine, and there we go. The same application running on two different servers using the same code, easily distributable. You could easily, as you can see from this, you can make it a lot more sophisticated than needed, and I try to keep it as basic as possible to show it to you, but it's pretty powerful. If you don't like working with the command line, there are other ways you can interact with Docker. Docker provides a REST API which you can tie into via any of the numerous different languages API libraries. On top of that, some people have created some nice UIs that will allow you to use a web browser to interact with Docker. One of those is one of my favorites called Shipyard from Evan Hazlitt. It's a Django-based web application that actually runs in a container itself. To get it going, you just have to pull his, as we show you right here, you just have to pull down the repository via the Docker index, and it will just start up, and you'll have your container up and running. We'll just copy and paste this command, which is basically docker run -p 8005 8000, his name, and Shipyard. And the 8005 8000 basically tells us we're going to run this on port 8005, but internally to the container it's going to be 8000 since that's what the application is going to look for. When we kick this off, what happens is behind the scenes it's going to pull down that repository, that Django image if it doesn't have it already, and start it up. Since I already had this downloaded, it's going to use that version. And when it starts it up, it does a bunch of startup things. It makes sure that you have the latest version of code. It will run some migrations to make sure that the database is all up to date. And if everything worked well, you'll see these messages here where it says basically everything is starting up successfully. You can Control C out of this. And if you do a Docker ps, you'll notice it's not running anymore. So what his command did is it told you to start it up, but it didn't say start it in the background. So what we're going to do is do the same thing, but we're going to start it in the background. Now if we do a Docker ps, you'll see that it's running in the background. And we can do Docker logs to see what the status is. It takes a couple seconds for it to get up to running, so it's good to test it out to make sure it works. So now, go back to Docker ps. It's been running up for 18 seconds. Let's make sure it works. What we're going to do is we're going to go to our IP address. We're going to do port 8005. Because that's what we told it was going to run on, and it's going to log in. And by default, the password is admin, username is admin, password is Shipyard. There we go. So when you start off, it doesn't have any configuration at all. So what we're going to do is we're going to add a host. So we say host add, we give it a name, we'll call it localhost, and the IP address is going to be the same that we happen to have here. So it's the IP address of my host that's running. Now we can see it's enabled. We can go into containers, and now we'll see that Shipyard is actually running inside of Shipyard. It's very meta. And we get some images. We'll show you all the different images that you have on this server. We don't have any applications, but we could go in and create one if we wanted to. And an application is basically a combination of more than one container to build up an application. You might have a database, you might have a queue, you might have a web tier, and so forth. An application is a combination of those. So here we go for host. With a host, you can disable them, you can remove them. With containers, You can attach to them, restart them, stop them, destroy them. You can also create one. What I'm going to do is going to create one using the base Ubuntu 12.10 image, and we're just going to pass in the bash command. And that's it. All these other variables are optional. We don't need to do any of those. We're going to pick the local host, because that's the host that we have configured for this. Now you can see we have a container sitting here. What we're going to do is attach to it. When we attach to it, it actually creates a WebSocket to Docker, and we can actually run commands from the browser on the container. So it's really sweet. So we can get all those different things that we normally get done all through here, the browser. And when we close, you just type exit like normal, and then you just close the browser window. Pretty sweet, huh? When we're done, you just say stop. It's going to make sure we stop, and we're back to where we were before. At any time, you can hit these little refresh buttons, and it'll update everything what you're doing. I think that's about it. But if you have a chance, check out Shipyard. It's really easy to install. It was basically all that you saw there. If you don't want to run it inside of Docker, there's some more instructions on their website how to get it up and running outside of Docker. And it's pretty straightforward. Thank you for taking the time to watch my video. If you have any questions, feel free to go to docker.io and you can find a bunch of information available to you. There's documentation. There's also a great getting started guide with an interactive tutorial that allows you to see all of the different things that Docker can do inside your browser without having to install Docker at all. Highly recommended. If you have any questions, feel free to tweet us at @Docker on Twitter.